Okay, so let us look at another improper integral, which is still seen this way. Okay, we assume this integral converges. Okay, and we just want to figure out, okay, what is the exact value for this integral. Since this is a type 1 improper integral, and what we're going to do is we're going to convert it into a limit problem, okay, which is b to 2 theta e theta d theta. Okay, so the integration for this theta e theta d theta here is actually so let me explain it a little bit here. So integral theta e theta d theta here, and what we're gonna do is we can use an integration by parts. So you can set u is equal to theta, v prime is equal to e to the power of theta, so u prime is 1, and then v, it's still e to the power of theta. Remember the integration by parts, it's uv, right? So it's a theta times e theta minus integral. Since it's u prime v, so it's e theta d theta. Turns out this is theta times e theta minus e theta. Okay. Of course, we should add a c, but you know, this is just a part of this work, so I omit that c. Anyway, when we convert it into a definite integral, theta e theta d theta, turns out it's going to be theta e theta minus e theta, right? So you make an evaluate between b and 2. Turns out this is going to be 2e squared minus e squared, and then minus b e to the power of b minus e to the power of b here. Okay. And so if you simplify a little bit, it's going to give us this e squared, right? And then minus, so maybe let's do this, b minus 1, and then e to the power of b into this one. Okay. All right. And then after we got this, we need to put our limit back. So it's the limit b goes to negative infinity e to the power of 2 minus b minus 1 times e to the power of b here. Okay. So in this problem here, what we can do here is, since this e squared is just a constant, it's just e squared, so all we care here is to evaluate, okay, what is the limit for this b minus 1 times e to the power of b here. Okay, so for here, I can tell you this part is going to be 0, but why is 0? Maybe let's be more specific here. So let's see, limit b goes to negative infinity. Let's see, b minus 1 times e to the power of b, right? So I can also write this limit as b goes to negative infinity. This is b minus 1, and then over e to the power of negative b. Okay, so you can see that now on the top it goes to negative infinity. On the bottom, e to the power of negative b, which b goes to negative infinity, then negative b gonna goes to positive infinity. So it's also infinity. So for here, we can apply the L'Hopital rule. So it gives us this limit b goes to negative infinity. This part going to be 1 over the derivative of this, which is negative e to the power of negative b. It turns out this result, it's a 0, okay? So that's why the whole thing equals 0. So go back to here. What we get here is, this is e squared, okay? So that's the solution. So the technique here is from here, converted into a limit problem, evaluated with integration by parts, and then put the limit back, and then do some evaluation for this limit. And also the evaluation for this piece, you're going to use the L'Hopital rule, and then put all these pieces together, and then we complete our problem. Okay, so hope you enjoy this video, and thank you for watching.